Starting a better phone.
Daddy, I'm the fully punch daddy.
ఏం చేద్దాం చెప్పు
ఏం చేయడం ఏంటి
అవన్నీ కొంచెం పొద్దునే తెలుసుకున్నాను
కదా చేయాలా అప్పుడు ఏం చేయాలి అక్కడ ఏంటి పక్కన చూస్తున్నారా
చూసుకో ఇక్కడ చూడదు కదా
ఆగండి మీరు ఫాస్ట్
అది చేత్తో కొడతారు కదా నేను అలా
పడిపోతుంది Class in the stand up.
Assignment.
Good morning, one and all.
Hindi.
Good morning, one and all.
Good morning.
So let me share my screen to you. Previous class, we discussed about predicate logic. So how to solve a particular problem or how to prove a particular statement as true or false. We have discussed about all those, right? So now in today's class, we will discuss about resolution, right? Resolution. So roll number 502. Roll number 502. LG 502. LG 502. Please mute yourself. G4. G4 Chaitanya. So in yesterday's class we discussed about predicate logic, right? So this is the example I had taken yesterday. So to prove that the question given to us is Marcus alive? So based on the statements given above, we need to prove. We need to get the answer for this. Is Marcus alive? So the answer here is Marcus is not alive. So how can I say that Marcus is not alive? So based on the previous statements I have, I need to prove that one. Okay. So in order to prove this particular not alive of Marcus Kamanov, I have taken two ways. I considered two ways to prove that not alive of Marcus Kamanov is true. Okay. So this is one of the way where I have substituted various values and I have proved that not alive of Marcus Kamanov is true. So how can I say that not alive of Marcus Kamanov is true, as none of the statements are left to be proved. That means if I get nil statements, that means, so here I got nil at last. See this one, at last I have got nil. That means no other well-formed formula or no other statement is left to prove. That's why I have got. Okay. So if I get like this, then I can say that the answer which I have considered is true. Okay. Next, here also I have considered another way to prove that not alive of Marcus Kamanov is true. At last I have got nil. That means no other statement is left to prove, right? So that's why this is also proved. So so here I have considered two ways to prove that not alive of Marcus Kamanov is true, right? In today's class, we'll discuss about resolution topic. Resolution, okay? So resolution means it is a process or a procedure that is used to prove that the arguments which are expressible in predicate logic are correct. It means the arguments which I am considering in predicate logic are correct. That means here also I have considered one the previous topic also I have considered a particular procedure where I have proved that the argument. So that is also argument. Not alive of Marcus Kamanov is an argument. So the argument there I have considered has been proved. That means what answer I'm considering is has become true. Okay, so here also resolution is a procedure that is used in proving that arguments which are expressible in predicate logic, arguments which are expressible in predicate logic are correct. Okay, so we can also extend this particular resolution to propositional logic also. You can use the resolution in predicate logic and also propositional logic. Okay, so this particular resolution process can be applied to predicate logic also, right? Next, so this can be used for logic and the predicate logic. Next, so this particular resolution produces proofs by refutation. So the process which we use here in resolution is refutation. Okay, so refutation means to prove the validity of a statement. This particular resolution attempts to show that the negation of the statement produces a contradiction with the known statements. So by using the known statements, I'm going to take the negation of the answer. I know the answer. Okay, I will. I know the answer. So the particular answer, I'm going to put negation. That means, for example, see this one. So I know that not alive of Marcus Kamanov is true. So now I will apply negation to this one. So that means negation the negation alive of Marcus Kamanov. Okay. So if I write like that, not of. That means negation of alive of Marcus Kamanov means alive of Marcus Kamanov. It will become alive of Marcus Kamanov. Okay, that is minus of minus means plus, like that. Negation of alive Marcus Kamanov. So it will become alive of Marcus Kamanov. So this particular alive of Marcus Kamanov. So I need to prove that alive of Marcus Kamanov is false. Here, not alive of Marcus Kamanov is true. So I will consider the negation. That means I will apply negation to the statement. Negation by applying negation alive means it will become alive. So alive of Marcus Kamanov, it will become alive of Marcus Kamanov. So I need to prove that it gets a contradiction. So if a particular thing and I prove it as a contradiction, then I can say that it is true, because I'm considering a false statement. That false statement cannot be proved. False statement cannot be proved means it will become true only, no, like that. Okay. So in resolution, I'm going to do this one, right? So resolution is a procedure, okay, where I consider the negation of the statement and I need to produce a contradiction with the known statements. Then I'm going to get the answer, right? That's it. So coming to the basis of resolution. So it is an iterative process. At each step, two classes. Each step, two classes will be there. One is parent class. Okay. One is parent class. Parent classes containing the same literal are compared or resolved, yielding a new class called the resolvent. So here I'm going to get two things. One is parent class. So by considering the parent classes, I'm going to get a new class called the resolvent that has been inferred from them. Next, so the literal must occur in I don't know why there is a disturbance. So please put yourself G0, number G0, roll number G0. Please mute yourself. Roll number G0. Please put yourself in mute. Don't disturb the class, please. I told you many times not to disturb the class. Still, some are disturbing the class. So if you disturb the class like this, so I can't tell with concentration, right? Right. So so um, hmm. so um, so here resolution. The resolution procedure is an iterative process. At each step, two clauses called the parent clauses containing the same literal are compared or resolved, yielding a new class called the resolvent. So I'm going to get the resolvent from the comparison of parent classes. Okay. So next, the literal must occur in positive form in one class and negative in form in another. That means I'm going to get two things. One is positive form and another one is negation form or negative form. Right. Next, so the resolvent is obtained by combining all of the literals of the parent classes except the ones that cancel. Except the ones that cancel, remaining all will be combined. Okay. Next, the class that is produced is an empty class, then a contradiction has been found. Next, now see this one. So the given statement is winter versus summer. So I'm going to consider not winter or cold. So I have been given winter or summer. Here I'm considering negation for that one. So negation winter or cold. So we can conclude that summer okay. So summer or cold. You can conclude that summer or cold. So not winter means summer. Not winter means summer only now, right? Not winter or not winter. Not winter means summer. So summer or cold. Like that. Next. So in predicate logic, the situation is more complicated since we must consider all possible ways of substituting values for the variables. So the theoretical basis of resolution procedure in predicate logic is Herban's theorem. So Herban's theorem tells us that to show that a set of clauses S is unsatisfiable, it is necessary to consider only interpretations over a particular set, called the Herban universe of S. A set of clauses S is unsatisfiable if and only if finite subset of ground instances of S is unsatisfiable. Next, the second part of theorem is important. So here, there's a procedure for proving the unsatisfiability, right? So in order to prove the statements using predicate logic, the statements and well-formed formulas must be converted into class form. So first of all, in the process of resolution, we need to prove the statements using predicate logic. Okay, so whenever I want to prove the statements using predicate logic, I need to consider the statements and well-formed formulas to be converted to class form. So when I need to convert the statements and well-formed formulas into class form, then only I can do resolution process. Okay. So first of all, to go further, we need to convert the well-formed formulas to class form. That is the first step, right? So now see how to convert the well-formed formulas to class form. So one method we examine in this particular resolution is all the statements are to be converted to normalized class form. First of all, the statements should be converted to normalized class form. Next, after that, we have to define a class as a disjunction of a number of literals. Next, a ground class is one in which no variables occur in the expression. Ground class means no variables will be there. Next, we need to have disjunction of number of literals. Next one, a horn class is a class which with at most one positive literal. So these are some of the classes here. So one is ground class and other one is horn class. Ground class means no variables will be there. Horn class means at most one positive letter will be there. Next. So to convert a sentence into class form, we need the following steps. To transform a sentence into class form, we need the following steps. So first one, eliminate implies. Implies is to be eliminated. Second one, so reduce the scope of each negation to a single term. So negation. So negation scope is to be reduced to a single term. Please first eliminate implies. Next one, scope of negation is to be reduced to a single term. Next, standardize variables so that each quantifier binds a unique variable. Standardize the variables so that each quantifier is a unique variable. Next, move all quantifiers to the left without changing the relative order. Quantifiers are to be moved to left side. Next one, eliminate their exist. Eliminate their exist. Next, drop for all. Next one, convert the formula into conjunction of disjuncts. So all the disjuncts conjunction. Conjunction of create a separate class corresponding to each conjunct. Standardize apart the variables in the set of obtained classes. Okay. Right. So now let us consider one example here. So before going to that one, we discussed the process of eliminating the existential quantifiers through a substitution process. This process requires all the variables are to be replaced by column function. Column function. Okay. So sometimes ones with no arguments are called column constants. No arguments. So a sentence having no arguments will be called as column constants. Example in predicate logic is, suppose we know that all Romans who know Marcus either hate Caesar or think that anyone who hates one is the universe. So now I need to prove this one, right? Right. So now see this particular sentence. So this particular well-formed, that means the sentence is to be converted to well-formed formula, and that particular well-formed formula is to be converted to class form. That is the thing we have to do, right? Now see this one. Okay, so I can represent this particular sentence in well-formed formula like this. For all x, Roman of x. So all Romans means I can write like this. All Romans means for all x, Roman of x, and so all Romans who know Marcus, So for all x, Roman of x, and know of x comma Marcus implies either hate Caesar or think that anyone is crazy. So hate Caesar. So either hate Caesar. Either hate Caesar means hate of x comma Caesar, or next for all y there exists z hate of y comma z. That means anyone means. So anyone means I can write like this. So for all y there exists z hate of y comma z implies think crazy of x comma y. So like this I have converted the sentence into well-formed formula. Right. Now let us see how to convert this particular well-formed formula into class form. Right. So first of all, I need to eliminate implies. That is the first step. Okay. So to transform a sentence into class form, first we have to eliminate implies. First we need to eliminate implies. Okay. So implies. So where do you have implies here? Here I have two implies here. Okay, one is after Roman of x and Nova of x comma Marcus implies height of x comma Caesar. And next one here also height of y comma z implies think crazy of x comma y. So these two are to be eliminated here. Okay, so two implies symbols are to be eliminated, right? So for all x, okay. So eliminate implies symbol using the fact that so I know that A implies B equal to negation A or B. A implies B equal to is equivalent to not A or B. So that means not A or B means A implies B. So now I can do like this. So A implies B can be written as A or negation B. Sure, sorry, not A or B. A implies B means not A or B. So I can write like this. So for all x, not A. Not A here is not A means not of Roman of x and Nova of x comma Marcus, or here B means height of x comma Caesar. So or height of x comma Caesar. Next or next here A is this one height of x by comma z. B is think crazy of x comma y. So now I can apply it like this. So not of okay. So or height of x comma Caesar. Next or for all y next negation of height of y comma z or think crazy of x comma y. That's it. Okay. Now implies symbol is eliminated by applying the formula A implies B equal to not A or B. Okay. Next, come to second step. So reduce the scope of each negation to a single term. Now I need to reduce the scope of every negation term, every negation to a single term. Now see this one. So reduce the scope of each negation to a single term. Now I can write this for all x, not of Roman of x or not know of x comma Marcus or height of x comma Caesar or for all y for all z for all y for all z not height of y comma z or think crazy of x comma y. That's it. Okay. So why I had like this? So see this one. So negation of negation p equal to p. That means negation of negation p equal to p. Next, negation of a and b equal to not a or not b. Next, not there exists x p of x equal to for all x negation of p of x. For all x negation of p. Next, negation for all x p of x equal to there exists x not p of x, like this. Okay. So, by using all these formulas, I can right. So next, now third step is standardize the variables so that each quantifier binds a unique variable. Okay. So standard variables so that each quantifier binds a unique variable. Now see this one. So if you consider this, for all x of x or for all x q of x, if I have been given like this, that can be converted to for all x p of x or for all y of Means each particular variable is to be binded to unique variable, or each particular standard variable can be converted to can be used to bind a unique variable. That means each and every variable should be binded with a unique variable, right? So for all x p of x or for all x q of x can be written like this: for all x p of x or for all y q of y. Next, fourth step: move all the quantifiers to the left without changing the relative order. Now write like this. So for all x, so I have three things here: x, y, and z. Okay, so for all x, for all y, for all z, not Roman of x, not Roman of x, or not no of x comma Marcus, or hate of x comma Caesar, or not hate of y comma z, or think crazy of x comma y. That's it. Next, fifth step is eliminate there exists symbol. So eliminate the existential quantifiers, that is there exist. So there exist is to be eliminated. Now, in our example, we don't have any existential quantifiers at step 4. Okay, so there is no need to eliminate the there exist quantifier. So that is, if we have any variable like this, that means for all y, president of y. Okay, so I can write like that. I can write like this. So it can be transformed to president of S1, president of S1. Okay. Next, for all x, there exists father of y comma x. That can be written like this: for all x, father of S2 of x comma x, like this. Okay. Now next, sixth one. Sixth one is drop drop the prefix. Drop the prefix from fourth step. Drop the prefix. So prefixes are for all x, for all y, for all z. Those will be eliminated. Now I'm going to get not Roman of x, or not no of x comma Marcus, or hate of x comma Caesar, or not hate of y comma z, or think crazy of x comma y. Next. Now seventh step is convert the formula into conjunction of disjuncts. Now I can write like this. So using the associative property, A or B or C equal to A or B or C. So now I can write like this: not Roman of x, or not no of x comma Marcus, or hate of x comma Caesar, or not hate of y comma z, or think crazy of x comma y. Okay. Next. So for example, if I have like this, winter or summer and wearing sandals, or wearing boots versus summer and wearing sandals, winter versus summer. Okay, so that is A or B or C equal to A or B or C. So I can write like this, right? Next, next one is now eighth step. Eighth step is create a separate class corresponding to each conjunct. Okay, now I can write like this. Okay. That's it. Okay. So this is how to convert the well-formed formula into class form, right? Next, now let us see how to use resolution in propositional logic. Resolution is propositional logic. So first, we first present the resolution procedure for propositional logic. So now let us see how to apply resolution in propositional logic. Okay. Now it expanded to include predicate logic. First, let us see how to apply in propositional logic. After, we can see how to apply resolution in predicate logic. Next, in propositional logic, the procedure for producing a proof by resolution of proposition P with respect to a set of axioms F is the following. So now see the algorithm for applying resolution in propositional logic. So you can call it as resolution propositional. Next, so first step is convert all the propositions of F to class form. Convert all the propositions of F to class form. Next one, negate P and convert the result to class form. Add it to the set of classes obtained in one. Repeat until either a contradiction is found or no progress can be made. Select two classes, call these as parent classes. Okay, first one is convert all the propositions of F to class form. Second one is negate P and convert the result to class form. Add it to the set of classes obtained in first step. Next, third one is repeat until either a contradiction is found or no progress can be made. In that, I can do three things. One is select two classes, call these as parent classes. Next one is resolve them together. The resulting class is called as the resolvent, which is the distinction of all the literals of both of the parent classes with the following exception. If there are any pairs of literals L and negation L, such that one of the parent classes contains L and other contains not L, then select one such pair and eliminate both L and not L from the resolvent. Okay. Next. So third step is if the resolvent is empty class, then a contradiction has been found. So if it is not, then add it to the set of classes available to the processor. Okay. So this is how to apply resolution in propositional logic. Okay. Now see this example. Now see this one. Let us consider few facts in propositional logic. Given axioms are P. Next, P and Q implies R. S or T implies Q. Now let us see how to convert P. P means I can write it as P in class form. Next, P and Q implies R. I can convert it to negation P or negation Q or R. That means A implies B means not A or B. So not of P and Q means not P or not Q. Implies will be converted to R. Okay, so R. Next, S or T implies Q. So I can convert it as not S or Q, not S or Q. Next, not T or Q, not S or Q. Next, not T or Q. I had like this, like that, A or B. So a negation of A or B means negation. That means I can write like this. So S or T implies Q means A implies B. A implies B means not A or B. Not A or B means not S or Q, not T or Q. Like that. Next one, T means T only. Like that. Okay. So not P or not Q or R. Okay. So not P or negation Q or R. Next, consider another one called not R. So now R and not R will get cancelled. Not P or negation Q will remain. Now consider Now consider P. Consider P. So P means that is whatever I have in previous things, that is a class form I'm considering here. So not P or Q. Here P is there. So P. Now P and not P will get cancelled. Not Q will be remained. Next one. So what are remaining here? So not T or Q and not Q. So Q and not Q will get cancelled. Not T will be remained. Now consider T. So T means T and negation T will get cancelled and I'll get nil value. Okay, that's it, right? So this is how to solve the resolution. This is how to apply resolution in propositional logic. Okay, so here I have an algorithm called as unification algorithm. So this particular unification algorithm is a recursive procedure. Okay, so which I can use in solving the resolution in propositional logic, right? So in propositional logic, in order to easily determine two literals and its contradiction, simply look for L and not L. In predicate logic, this matching process is more complicated. And since the arguments of predicates must be considered, for example, man of John, that means not man of John is a contradiction, while man of John and not man of John is not. Okay. Next, so in order to determine the contradiction, we need a matching procedure that compares two literals and discovers whether there exists a set of substitutions that makes them identical. So that this particular recursive procedure is known as unification algorithm. So here unification is applied like this. Okay. So in order to unify two literals, or in order to apply unification on two literals, we can do like this. So first you have to check if their initial predicate symbols are same or not. If their initial predicate symbols are same, then proceed further. Otherwise, we cannot unify them. So so only they can be unified. So two letters can be unified only when their predicate symbols are same. Okay. For example, try assassinate of Marcus, Caesar. Next, hate of Marcus, Caesar. I can apply like that. Okay. Next, if predicate symbols match, we can check the arguments. We must check the arguments one pair at a time. So one pair at a time can be checked. So the first matches, we can continue with the second, and so on. Now to test each argument pair, we can simply call the unification process recursively. The matching rules are as follows. Different constants and predicates. Different constants or predicates cannot match. Identical one will match. Constants or predicates should be identical. Otherwise, we cannot unify them. Next, variable can match another variable, any constant or a predicate expression. Okay. For example, suppose you want to unify the expression like this: p of x comma x and p of y comma x. The two instances of p match fine. Okay. Next, we compare x and y and decide that if substitute y for x, they could match. Then we're going to write substitute y for x. That means y by x. That means instead of y, I can write x. Next, the next match x and z. We put this substitution z for x. But we can substitute both y and z for x. I have not produced a consistent substitution. That means two things cannot be applied for one thing. That means for x, I'm applying two things. One is y and another one is z. I cannot do like that. So only single variable can be matched or single variable can be substituted. Okay, like that. Okay. So we'll discuss the remaining topics in the next class. Today only 59 members are present. No, why? So I'll continue the remaining topics in the next class. Okay, thank you.